प्रिय दोस्तों, आज का इस वीडियो में हम आपसे डिस्कस करेंगे न्यूटन्स लॉ ऑफ ग्रेविटेशन के बारे में। Newton's law of gravitation statement that any particles of matter in the universe attract any other with a force varying directly as the product of the masses and inversely as the square of the distance between them. In symbol, the magnitude of all the attractive force F is equal to the G, the gravitational constant, a number the size of which depend on the system of unit used and which is universal constant multiplied by the product of the masses m1 and m2 and divided by the square of the distance r ratio F is equal to G m1 m2 oblique r square. Isaac Newton put forward the law in 1687 and used it to explain the observed motion of the planets and their moons, which has been reduced to mathematical forms by the Johannes Kepler early in the 17th century. Newton's law of motion, a relation between the force acting on a body and the motion of the body, first formulated by the English physics and mathematic Sir Isaac Newton. What are the Newton's law of motion? Newton's law of motion relate an object motion to the force acting on it. In the first law, an object will not change its motion unless a force acts on it. In the second law, the force of an object is equal to its mass time and its acceleration. In the third law, when two objects interact, they apply force to each other of equal magnitude and opposite direction. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. This postulate is known as the law of inertia. The law of inertia was first formulated by the Galileo Galilei for the horizontal motion on the earth and was later generalized by René Descartes. Before Galileo, it had been thought all horizontal motion required a direct cause, but Galileo deduced from his experiment that a body in motion should remain in motion unless a force caused it to come to the rest. Basketball. Newton's law of motion. When a basketball player shoot a jump shot, the ball always follow an arcing path. The ball follow this path because it motion obey the Sir Isaac Newton law of motion. Newton's second law is a quantitative description of the changes that a force can produce on the motion of a body. It states that the time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. The momentum of a body is equal to the product of its mass and its velocity momentum. Like the velocity, it is a vector quantity having both magnitude and direction. A force applied to a body can change the magnitude of the momentum or its direction or both. Newton's second law is one of the most important in all of the physics. For a body whose mass m is constant, it can be written in the form F. F is equal to ma, where F stands for force and A stands for acceleration, are both vector quantities. If a body has a net force acting on it, it is accelerated in accordance with the equation. Conversely, if a body is not accelerated, there is no net force acting on it. Newton's third law state that When two bodies interact, they apply force to one another that are equal in magnitude and opposite in direction. The third law is also known as the law of action and reaction. This law is important in the analyzing the problem of static equilibrium where all forces are balanced. But it is also applies to bodies in uniform or accelerated motion. The force it describes are real ones, not mere bookkeeping device. For example, a book resting on a table applies a downward force equal to its weight on the table. According to the third law, the table applies an equal and opposite force to the book. This force occurs when a weight of the body causes the table to deform slightly so that it pushes back on the book like a coiled spring. Newton's law first appeared in the masterpiece Philosophiae Naturalis Principia Mathematica 1687, commonly known as Principia. In 1543, Nicolaus Copernicus suggested that the sun rather than the earth might be at the center of the universe. In the intervening years, Galileo, Johannes Kepler, and Descartes laid the foundation of a new science that would both replace the Aristotelian world view inherited from the ancient Greek and explain the working of a heliocentric universe. In the Principia, Newton created that the new science. He developed his three laws in order to explain why the orbits of the planets are ellipses rather than the circle, at which he succeeds, but it turns out that he explained much more. The series of events from Copernicus to Newton is known collectively as the scientific revolution. In the 20th century, Newton's laws were replaced by the quantum mechanics and relativity as the most fundamental law of physics. Nevertheless, Newton's law continued to give an accurate account of nature except for a very small bodies such as electrons or bodies moving close to the speed of the light. Quantum mechanics and relativity. आशा करती हूँ आपको मेरा ये वीडियो पसंद आया होगा। आप इसे अपने बच्चों को शेयर करिए जिससे बच्चों का नॉलेज सुनने से और समझने से जल्दी ग्रैस्प करता है, जल्दी उनके दिमाग में रहता है। इसलिए ये वीडियो मैंने आज आपके लिए लेके आई हूँ। Thank you for watching my video. Please like, share and subscribe my video.